Locating zeros of polynomials. The rational zero theorem is one of many tools that we're going to study that will help us to find the real zeros of polynomials. So whenever we talk about the rational zero theorem, we're really looking for everything that is possible, all of the possible real zeros of this particular polynomial. I think the best way to talk about this theorem is to just work a problem. The first thing that you want to do is make sure your polynomial is written in descending order. After it is, your constant will be your p, and your leading coefficient will be your q. So if p is 16, I want to list all the factors of 16. That would be 1, 2, 4, 8, 16. Now we want to find q. Q is 3, so let's list all the factors of 3. Positive and negative 1 and 3. All of the possible rational zeros will be p over q. So you take each of these p's, put them over each of these q's. So you're going to have a 1 over 1, 2 over 1, 4 over 1, 8 over 1, 16 over 1. Do the same thing with the 3. 1 over 3, 2 over 3, 4 over 3, 8 over 3, and 16 over 3. So out of all the numbers in the whole world, only these in this list are possible zeros for this function. I should clarify, possible real zeros of this function. So what we want to do is figure out which ones actually are the zeros. Well, we could go through and do some synthetic division. Just to review, we'll put 1 on the outside. On the inside, we'll put our 3, negative 8, negative 20, and 16. Bring the first one down, multiply, add, multiply, add, multiply. Well, we know that this one is not going to give us 0, so we don't even care about it. What we want to do is keep doing this process until we get one that gives us a 0 here. Another way you can do this is to just use your calculator. If you plug in f of 2 into your calculator, you'll get some number. F of 4, you'll get some number. You keep doing this until you find the one that gives you 0. So I'm going to pause the recording now and do just that. So what I just found was if we plug in negative 2, we do get 0. So what I want to do is use synthetic division with that negative 2. 3, negative 8, negative 20, 16. Bring the first one down and multiply. Add, multiply, add, multiply, add. Now we knew this needed to be 0. If it didn't, then I would have done something wrong. So right now we have f of x is equal to x minus this number and this line, so 3x squared minus 14x plus 18. Now we want to see if this will factor, and if it will not factor, then we'll have to use the quadratic formula to find out the other two factors of this polynomial. So now what we have, after we determine that it will factor, we have x plus 2. When we factor this other side, we're going to get x minus 4 and 3x minus 2. Okay, I was just double checking to make sure that does work. So to find all the actual zeros, you just need to set each of these equal to 0. Well, you already know this one gives you a negative 2. So x equals negative 2. The next one, if you set this equal to 0, you find x equals 4. For the last one, 3x minus 2 equals 0, you find x equals 2/3. So your zeros for this function are these three values. And if you notice, all three of those are in this list right here. So if you're ever asked to find the possible rational zeros or the possible real zeros, you'll be looking for this line right here. All your P's and Q's. Okay, let's do the same thing for this problem. Our P is -9 and our Q is 24. So factors of -9 will be 1, 3, and 9. Factors of 24, 1, 2, 3, 4, 6, 8, 12, and 24. So our P's over Q's will probably make a really big list. Positive and negative. 1 over 1, 3 over 1, 9 over 1. 1 over 2, 3 over 2, 9 over 2. 1 over 3, 3 over 3 is 1, 9 over 3 is 3, so we don't need those two. Then we have 1 over 4, 3 over 4, and 9 over 4. Then we have 1 over 6. 3 over 6 is 1/2. We don't need that one. 9 over 6 is 3/2. We don't need that one. So then we have 1 over 8. 3 over 8. 9 over 8. Then we have 1 over 12. 3 over 12 is 1/4. And 9 over 12 is 3/4. So then we have 1 over 24. 3 over 24 is 1/8. I have that one. 9 over 24 is 3/8. We have that one. So those are all our possible rational real zeros. It's kind of redundant, but that's the list. So now what we need to do is find the ones that actually work, or just find one and then we'll move on from there. So I'm going to pause the video again and start trying. We'll plug in one of these at a time into this function and see which one gives us 0. So we find out that 3 works. So whenever, let me make a note of that, g of 3 is equal to 0, which means 3 should be a 0 of this function. So we'll put 3 on the outside and perform synthetic division. Are we missing anything? 4, 3, 2, 1, 0. We're not. So 24, -60, -30, -15, -9. I guess you've noticed by now that my recording device doesn't like negatives or small straight lines. Okay, 24, -60, -30, -15, -9. So we bring down the first one, and then we multiply. And then we add. And then we multiply. And then we add and multiply and add and multiply and add. So if I were to write this out factored now, I would have x minus 3 because of this one, and then 24x cubed plus 12x squared plus 6x plus 3. Now we need to try to factor this one. Well, I do see that we can factor a 3 out. So let me do that. 3 times x minus 3, so I factor a 3 out of this factor. 8x cubed plus 4x squared plus 2x plus 1. Could we factor by grouping on this? Let's see, come over here to the side. 8x cubed plus 4x squared plus 2x plus 1. we can factor out a 4x squared. We'll be left with a 2x plus 1. We can factor out a 1 and we're left with 2x plus 1. Factor out the 2x plus 1 and we're left with 4x squared plus 1. Okay, so far we have this. 3 times x minus 3 times 2x plus 1 times 4x squared plus 1. This will tell us that the zeros are, well, we know this one is 3. This one, if we set that equal to 0, 2x minus 1 equals 0, 2x equals 1, which means x equals 1/2. 1/2. But then what about this one? We have 4x squared plus 1 equals 0. Move the 1 over. We have 4x squared equals -1. Now we divide both sides by 4, so x squared equals -1/4. And we take the square root of both sides. So x is equal to plus or minus, the square root of 1/4 is 1/2. But we have a negative, which means we have an I, so 1/2 I. So our 4 solutions are 3, 1/2, and positive and negative 1/2 I. These are all the, I was going to say solutions, but these are the zeros to that function.